This is the fourth in a series of videos on more probability, going into some probability problems in some more detail. And in this video, what we want to do is we want to talk about what are called tree diagrams. And the interesting thing about tree diagrams is there's never a problem where you have to use it to your tree diagram, and there's a lot of problems that you can. So there's kind of an art to choosing when you want to use a tree diagram and when you don't. And the oftentimes they're used when you have a series of problems that are successive, right? So let's do a simple example. Let's find the probability that, let's do an experiment first where you flip a coin and then you roll a die. And you want to find the probability that you get a head and a number greater than 4. Now this is actually a problem you could do without a tree diagram, fine. But I just want to use this as an illustration of a tree diagram. So in this problem, if you can think about this, you can think about this as two successive steps. First you flip a coin and then you roll a die. So you start here, and the first thing is you either get a head or a tail. And the probability of getting a head is 0.5, and the probability of getting a tail is 0.5. Now, once you flip a coin, you're then going to roll a die, and you're going to see if you get a number which is greater than 4 or less than 4. Less than or equal to 4, that'd be 1, 2, 3, 4 out of 6, so that'd be 2/3, so that's about 0.67 or 2/3. And the probability of greater than 4 would be 1/3 or 0.33. This would be less than 4, would be, let's do it in fractions, 2/3, greater than 4, 1/3. And then if you notice this outcome right here would be getting ahead and then rolling a number less than 4, so you just multiply these two probabilities. So in this case it would be 1/2 times 2/3 or 1/3. And this one would be, right, this one would be ahead and then a number greater than 4, where this one would be ahead, number less than or equal to 4. Getting ahead and then getting a number greater than 4 would be 1/2 times 1/3 or 1/6. This node right here would be 1/2 times 2/3. 1/2 times 2/3 would be 1/3. And that's getting a tail and getting a number less than or equal to 4. And here it would be getting a tail and a number greater than 4. So that's 1/2 times 1/3 or 1/6. And what that does is it just illustrates how to solve this problem. If you want to find out the probability of flipping a coin, getting a head and getting a number greater than 4, you go head, a number greater than 4, the answer is 1/6. Now again, this isn't necessarily the easiest way to do this problem, but it illustrates how to do a tree diagram. Now let's do a problem in which it is more apt to use a tree diagram. So let's say that we have a two-stage process. First, you're going to apply to college. And let's say you have a 60% chance of going to UCLA. And you have a 40% chance of going to college somewhere else. Now, if you go to UCLA, let's say you have an 80% chance of graduating. And if you go somewhere else, let's say you have a 70% chance of graduating. And let's just say that you really want to go to UCLA, so you're going to go to UCLA if you get in. If you don't get in, you're going to go somewhere else, but you're not as excited, so you have a lower probability of graduating. It's just an example. So if you think about this, there's a two-stage process. First, you're going to apply to college, and you're either going to go to UCLA or another school. And then once you apply, once you decide what college you're going to, then you're either going to end up graduating or not graduating. And so let's draw a diagram, and then the first question is UCLA. So you start here, and you're either going to go to UCLA or you're going to go somewhere else. Now, the probability of going to UCLA is 60%, and the probability of going somewhere else is 40%. Now, once you go to UCLA or not, you're either going to graduate or not, but that depends on whether you go. So if you go to UCLA, you're going to graduate 80% of the time, which means you're not going to graduate 20% of the time. If you go somewhere else, the probabilities are similar but not the same. You're going to graduate 70% of the time, and you're not going to graduate 30% of the time. So you have 4 different outcomes: here, 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 and here. And we can calculate the probabilities, and we calculate the probabilities by simply multiplying. Now you have to be very careful when you multiply here. This is 60% times 80%. So 60% times 80% is going to be 48%. 0.48. This is 60% times 20%. That's going to be 0.12 or 12%. 0.4 times 0.7 is 0.28. 0.4 times 0.3 is going to be 0.12. And these should add up to 100. 48, 60, 88, 100. It does. So the probability of you graduating from UCLA is 48%. What you can also do is you can figure out what's the probability that you graduate overall. Now the key of the graduating overall is you're going to graduate by either graduating from UCLA or by graduating from somewhere else. And then, so that's 0.48 and 0.28, and you're going to have to figure out if you're going to add or you're going to multiply those two. Well, here's the key about adding and multiplying. In this case, we go to UCLA and we graduate, which means we multiply. But here, in order to graduate from some college, you're either going to graduate from UCLA or graduate from another college. Generally, when we say or, then you add. When you say and, you multiply. So you would add these two together, and that's 16, carrier 1, 6, 7. So the good news is that you, even though UCLA is your first choice and you only have a 48% chance of graduating from UCLA, you actually have a 76% chance of graduating overall. And that's how you do tree diagrams. Now the key to tree diagrams is that you can almost always use them, but they're not always the most helpful tool. Just use them when you think they're most useful. And they're most useful when you have successive events, especially when the probabilities change based upon what happens in an earlier stage.